coming over, for joining here. It is my great pleasure that I can share some thoughts with you on this new technology. Today, everyone is talking about AI. So let's say one of you have your newborn child, and by the time that child goes to kindergarten, okay, we are having a possibility that his class teacher in kindergarten would probably be as good, a better AI assisted robot. So we are talking about the cognitive abilities assisted by AI taking over far better than human intelligence, and all this in the next 2 to 3 years timeline. So I would like to give you a very realistic perspective of what is happening in the world today on AI. And I'm talking all of this in the last 2 years, whatever that is happening. Firstly, AI is hugely impacting. We are hearing that. We are not yet, experiencing it, but very soon we are likely to, because that's the amount of change that AI is actually creating here. Firstly, AI is impacting a huge amount of energy in the energy sector. In 1975, the cost of solar energy, and solar energy I take because even 0.01% of the solar energy that falls on planet Earth, if it can be tapped, it is enough for the entire human consumption. So solar energy came about in 1975. Until now, the prices have tumbled down by almost 99, little more than 99%. Yet, it's not as cheap as gas or coal. We still are fighting with photovoltaic cells cost. We are fighting because of batteries that needs to get better to hold on during those times when the sun is not out there brightly shining. So what is AI doing here? In November 2023, Google came out with this genome AI. Till then, the entire world knew about 20,000 inorganic compounds. So this genome AI almost overnight got these 20,000 inorganic compounds in the entire history of mankind. 20,000 identified inorganic compounds overnight became 4,21,000. So today we have 4,21,000 inorganic compounds which are today being used to research further for better photovoltaic cells, for better battery life. So this is likely to completely alter the energy space so that energy from the solar can actually become extremely cheap, too cheap to the extent of almost being free. The second area is manufacturing. And when I say manufacturing, we are talking about the biggest cost of manufacturing is human labor. Now, robotics is actually completely altering the entire phase of manufacturing. And when I say robotics, we are talking about replacement of human labor in many, many places, from irrigation, from farming, down to the most sophisticated factory in the world. We are having robotics planted everywhere. And we will see more of that down the line. But then robotics is not just assisting human labor. It is also doing raw material extraction. So for example, we are going to replace many of the very expensive materials today, zirconium or silicon or carbon-based graphene. All of this is likely to get replaced. All these rare earth elements are likely to get replaced by other newfound elements. And why do I say newfound elements? Because AI is exactly doing that. We're talking about identifying, inventing, discovering new replacements for rare earth elements, and therefore we are looking at extremely cheap and abundantly available material, manufacturing material. So the changes that this AI is bringing onto material sciences is exponential, has never been ever happened in history. So that's our on the manufacturing side. On the computing, on this talking on manufacturing, on the computing side, we all know the Murphy's law. 18 months, the whole computational power doubles. But I'll tell you what, the average in 2023 of a chipset, computer chipset, that it can do 48 billion calculations per second. 48 billion calculations per second. Now, from that time, and you have this NVIDIA coming out with their GPU, graphical processing unit, B200. And that was one of these early GPUs that came. And it catapulted this 48 billion 10 times more to more than 500 billion. So 500 billion calculations per second is what we are seeing now and growing further up. Now, so computers and computational capabilities are exponentially increasing. And all this B200 is an AI-assisted ASIC. So we are here talking about exponential growth that manufacturing is likely to see. And the third and the most important area is what we are all assembled here for: medicine. Now, when I say medicine, we are talking about one of the large issue about medicine is medicine today an exact science? The answer is a big no. I mean, every doctor has his own way of prescribing, diagnosing. And I'm not a medical expert, but I've been experiencing medicine, and I know, just like any other human. But so we are talking about customization of, in terms of geography. If there is a disease outbreak, we get to know that in a flash. We understand what is going on, not only with respect to a particular geographical area. We also get deeper understanding into every human, because every human has his own complications, has his own personalization demand. So we are also looking at, this webinar today will be more focused on healthcare retail, whereas healthcare research is one huge area we are not going to touch upon today. I'll just touch this one element with respect to healthcare research. 3 months back, the very first AI-assisted and AI-designed medicine, which was on idiopathic pulmonary fibrosis, which is a lung disease, I understand. So that got into phase 2 trials. And that's the very first AI-designed medicine. And we are having a host of other AI-assisted drugs that are coming up for trials now. So over a period of time, we are likely to see very personalized drug prescriptions. And this is another very fact of the matter. If you actually go to DeepMind, Google DeepMind, and there is this project called AlphaFold. Now, there was this human understanding of shapes of about 190,000 proteins, which was up there till about 2.5 years back. So once this DeepMind came, where DeepMind is an AI-assisted project, in the name of AlphaFold, and once this came, this 190,000 catapulted to 200 million. Today we have 200 million known proteins, with shapes, which can assist in development of new drugs. That's the kind of changes we are talking about. Proteins today. We're talking about organelles tomorrow, cells or tissues, organs, and maybe the whole human body. We're talking about a dramatic change that is likely to take place. And all this is not Star Wars fiction. We're talking about what is already happening and what is likely to happen in the next 24 to 48 to 36 months time. So in about 36 to 48 months time, you are likely to see the impact of all of this happening here. Now let's get into our today's conversation, which is on generative AI. Renuka, is my screen there?
Yes, Ram, we can see the screen. You can start the presentation.
So now we do not have time today to to cover the entire spectrum of AI. But I'll quickly tell you what we are trying to do. We're trying to introduce you into AI. Just an introduction to how you can begin to use AI. So we have huge amount of challenges in any hospital, any clinic. We have patient experience, which is a problem. People wait. I go to my doctor. For that 10-15 minutes I spend with my doctor, I wait for 90 minutes. So we have many other administrative issues, operational issues, documentation, diagnosis, prescription, all of this. Now, how are we going to solve all this is what I'm going to take you through. We are going to show you a demo at the end of this, and later on there can be a free flow question and answer session as well. We are looking at healthcare. We are in the cusp of this huge change, but already a lot of technology is already infused into healthcare. But today we are talking about healthcare, which is much less human driven and much more technology driven. And that is the transformation that we are going to be, that's the cusp of this time that we are talking. So the need to adopt AI or any other technology is not a luxury anymore. These innovations are today a necessity. So we are talking about bare minimum needs of what one needs to do to get into this technology transformation with respect to healthcare. So there is a lot of latest trends that is impacting the hospitals, clinics, and diagnostic centers. But all this has to be assisted by technology backend. Now, what are these 6 big technology trends that we are looking at? Big data. Now, hospitals generate huge amount of data. Recently, we were talking to a hospital who said they have 20 years of patient data, which they would like to monetize, and they do not know how. So that's the big data area. Huge amount of data, all scattered, running, stored in silos. We need to create a classification, categorization of all that data, bring it into one big data lake, and then begin to analyze that particular thing. So big data is a huge opportunity on technology. It's projected, no? Somebody is here saying that the PPT is not projected. Renuka, is that all right?
The screen is not moving, sir. Probably you actually have shared a wrong screen, I think, wrong window.
Okay, the screens are not moving. You are still on my first slide, is it?
Yeah, it's not in the PowerPoint mode.
I don't know. Let me stop sharing and then start sharing again. Is this on?
Still not in the PowerPoint mode.
What is PowerPoint mode? I'm PowerPoint show.
show. Yes. See that.
One second. So my screen is not visible now, right?
Yes.
Okay, now I'm sharing this. Okay, let me share my entire screen. Let's see what happens.
Share the other screen.
Yeah. Is it good?
Yes, this is better.
Great. Are we seeing the slides now?
Yes.
Okay, great. So sorry about that. So blame Microsoft. Okay, so big data is that one big area where you can all that idle data lying in patient data, diagnostics data, whatever, all that put together, and then do some deep drill and then come out with meaningful summary of what can be done next. Remote patient monitoring is another big area. Today we know, especially after COVID, a lot of Zoom calls and all of that stuff. So people wearing watches. So this Neuralink is coming up. All of this remote patient monitoring is another one big area. Already there, yet much more to come. Virtual reality. So before a surgeon gets into an operation theater and they want to make sure that everything is all right, they want to do a simulation of the operation, and that is possible also. So today, virtual reality can give the experience before the experiment. So we could do that as well. Artificial intelligence, we're talking about it. So I'll skip that for the moment. Telemedicine. So telemedicine has been on for a couple of decades now, is very much the part of our entire India story as well. These days, this ABDM, Ayushman Bharat Digital Mission is there, then Ayushman Bharat Health account. Everybody is going to be given an ABBA card so that, all of this is telemedicine. Only due to telemedicine can all of these get possible. So for those who may not know what ABBA card is, please go check out what ABBA card is. It's a Government of India initiative, phenomenal initiative to make sure that there is a complete digitization of every single individual's medical record. And then finally, the fintech integration. Eventually, that's what counts. We all, everybody wants to make sure that whatever we give is all integrated, is properly built out, and delivered. So the business goes on. There is one big important element with what you're seeing here in this slide. And I'll tell you, that is the trust factor, the factor of trustworthiness. Now, I just saw a recent report that 48% of surgeries that happen in our country could possibly be avoidable surgeries or induced ones. Now, with the help of technology, we are not just talking about assistance and aiding. We are also talking about capability of the individual to figure out, whether the technology suggests a surgery or not. So the whole big change that we would not only see with respect to improvement in quality of healthcare provided, we also look at correctiveness of the healthcare system, making sure that all the moralities get set into place. So again, like I said, we are only introducing you into this AI space. Now, we have administrative burdens in hospitals. We have manpower issues. We have doctor skill issues. We have operational issues, delays because of all of that. So we have administrative burdens. We have diagnostic accuracy issue. So one doctor diagnoses something, the other one does not. There is one experienced doctor who leaves the hospital, takes the skill along with him because he cannot, he is no longer present. But then he leaves a whole lot of documentation. Now the skill today from that experienced doctor can actually get derived through this AI. So we are talking about diagnostics of a doctor. He does the human in the doctor does the diagnostics, wants to revalidate, and so validates it with the AI assisted tool, which can actually sift through millions and millions of records and come out with more precise diagnostics. We're talking about personalized prescriptions. So one size does not fit all. So, we're talking, interestingly, I saw a website called glasshealth.ai. Now, Glass Health says, okay, you have ABC issue. This is your medication. Go ahead, take it. So this is the diagnostics, but then it doesn't work. Our food system is different. Our ecosystems are very different. Our lifestyle is very, very different. Everybody requires the geographical customization of prescriptions is a necessity thing that we need to take care of. So we're talking about personalized prescriptions down to the detail of that individual, not just with respect to the geography. And we have patient engagement. How happy is the patient? How clearly is he being communicated? How often is he being interacted with? Can we automate all of this so that the patient really feels that he's being well attended to? Moving on. So we're talking about huge amount of data that AI actually will sift through, analyze, and correlate, and give you details based on the demand. So rather than discussing, we learn faster while we discuss than sitting in a corner and reading books. Generative AI is such an interactive tool. You can begin to interact with it, and it learns, it relearns, it learns over a period of time. So by the time you spend a few months with the generative AI, it has learned so much that it becomes an expert by itself. So generative AI can give you very enhanced diagnostics, can give you very accurate interpretations based on medical images. So it can actually look at pathology results and give you quick answers. So the diagnostics becomes much more easier. This is not to replace human diagnostics. Human diagnostics is there for the moment, but over a period of time, human diagnostics can very well get replaced by AI-assisted diagnostics. We're talking about medical imaging, where generative AI can actually improve the accuracy of interpreting the medical images, all of your X-rays, MRI, CT scans, etc. The images can actually be very precisely scanned by an AI tool, and even if a human eye would miss something, the AI would not. And the pathology, not very long back, we used to wait for hours or days to get a pathology report, but not anymore. With AI, all of this can be actually almost immediate, and you never miss anything. So we're talking about personalized treatment, tailored therapies, all getting knitted together with the individual in focus. And once a doctor told me, if only I spend 10 minutes talking general stuff with that patient, my ability to diagnose the patient is far better than just giving him symptom-based prescription. So he may have a problem beyond the symptom. So these kind of time-bound, your doctor is forced to look up at so many number of patients. If only we can cut down the time taken for clerical activities, and the doctor understands everything, comes over, the patient comes over. The whole process is actually already very well understood. Like any of your, when you call a bank, the bank already knows that you are calling. This is your number, this is your bank account, and they have your entire history. And then they ask you, what do you want now? Likewise, a doctor will be able to check with that particular patient more. And we're talking about predictive analytics. Predictive analytics, we'll drill down a little more. Analytics is highly underutilized at the moment. But then analytics, not only with respect to that individual patient, but we're also talking about a possible outbreak and or a pattern that we are seeing in one particular geography over a longish period of time. So all of these analytics can actually get analyzed and then presented, and then a predictive activity can also be visualized. So then coming on to the administration, patient engagement, resource management, we also need clinicians to be happy and very well engaged. So we're talking of all of that, where your paperwork is reduced, your form fillings are reduced, your summarizations are automated. So your need for clerical demand is drastically reduced. Therefore, the number of people assisting you to do all your back-end jobs comes down. Automation takes over through AI-assisted applications and AI-assisted analytics. Now, let me go through to some very simple two cases. Okay, one is an OPD visit with the general. Somebody comes in. So today we have the appointment is booked over whatever means, and so there is a nurse attendant, then there is a doctor consultation, and then a physical or a digital prescription. So this is the today's way of doing it. But however, when we have a AI assisted backend coming up, so the patient understands, at any point of time can fix ask for a query, get answered for their queries. So there will be much less dependency on any human assistance to answer a particular patient, and then accurate information gets captured. So the patient knows what he needs to be doing, and whenever, at any point of time, 24 hours. So the documentation part, so the wait time gets phenomenally reduced. There is much less burden on the documentation. And then the patient to nurse face time gets increased. So the nurse actually knows what tests will have to do with the patient and goes about it. So there is no more questioning and answering there. So these improved efficiency gives more time to attend to more patients or spend more time with the one particular patient. So then moving on to step 3, we have therefore increased conversations and revenue leakages. So every step gets calculated, gets documented. So there is nobody missing out something. So we're talking about electronic medical records being analyzed, the compliances and outcomes also being precise. And finally, so therefore we have a high quality medical summary, we have an increased productivity output, the patient gets time, much more longer time spent, and we have more accuracy in this whole process. Or on a clinical or a non-clinical act. So we are talking about clinical documentation, decision support. So when you diagnose, you have a revalidation to diagnosis. When you prescribe something, you have a revalidation to prescribe with the AI tool. So the AI tool can actually suggest a prescription. You validate with your prescription before giving it to the customer, to the patient. Or for that matter, today a lot of marketing gets done. So you have targeted marketing. You have you can create on the go content specifically targeted at that personnel, and to tell him or tell her that your time is here, you need to come, we have something going on here. So enticing, enabling people to and keep them engaged. So overall, we are talking about a lot of digital front door. So a lot of self-service. The digital part gets most of this done. And the in-hospital engagement increases. So there are n number of AI tools coming up, and therefore which will assist in the billing, query, or the HR operations gets much more streamlined. You know who to be going to, who is available, who is not available. What is the time spent by every single nurse or every single doctor? So all of this creating more efficiency within. Now, this in a very broad sense is what AI could do. Now, what is happening today? We're not talking of something that is future, like I told you. When Google introduced Vertex, which is a Gen AI search experience, Vertex integrates patient information into one single system and streamline access, so the patient records, everything gets saved there. So that way you never lose a record. So Gen AI is already helping in educational content. So on the patient condition and generating very tailored information about health management. And there are assisted chatbots, which can actually not only suggest what you need to be doing, it can also tell you what is your present status, your health status. It can tell the patient what has to be done next, when is his next visit, who he need to meet, what time he needs to meet, remind him about all of that. And then deep analysis of the huge amount of profiles that we get. We go analyze it in depth to offer personalized, precise, effective medical care. Now, this deep analysis is what is extremely important. A lot of organizations, hospitals have, in my market research, during my time of market research, complain that, the skill is one big element. So they are dependent on a few doctors. So the younger generation obviously wants to keep checking. So this deep analysis is one huge capable replacement there. And AWS, Amazon, it has a health imaging app. Now you can save all your medical imaging, can be stored at less than 50% of the cost than what is happening today. Or the health records can all be put there, updated, accessed anytime, 24/7. Interestingly, GE Healthcare and this MGB, Mass General Brigham, they are partnering. They're interesting stuff. They talk about, when do you need a doctor, where do you need a doctor, and provide you right away. So they have this radiology operations module that will reduce costs and simplify administrative work. All of this is happening today as we take this forward. Now coming to what is this webinar for? This webinar is not to just give you, the cloud level, 35,000 feet gyan, but we are telling you all of this is possible to be implemented in your clinic, in your hospital at a very, very low cost. We are talking about a product called OLGPT that we have generated. Now, we've designed this. Essentially, we are talking about modernizing human-machine interface. I have explained all over. So there is a lot of human-machine interface that you can enable in your clinic, in your hospital. Secondly, we are talking about a lot of analytics. You collect data. Every day that your data is increasing. All of this data we can deep dive. We can have this OLGPT can actually skim through and give you much more precise information on diagnostics and prescription. And even finally, on the telemedicine or the chatbot, the patient experience. So we have a chatbot, simple chatbot that can assist you in doing all of this. These are the three very crucial, very capable things that this OLGPT can do. And what cost does this come at? This comes at an extremely affordable cost. All put together, you can even begin at about 50,000 rupees a month. Of course, it depends. There are two variables here. How many people you want to give access to? How much of data is there? These are two big variables that will define your cost, because everything, when it has to be accessed or it has to be stored, huge amount of data has to be stored. All these are variables, but you can still start for a medium size clinic or hospital. 50,000 rupees a month is good enough to get started. And mind you, cloud costs are always coming down. So as we go forward, we're not looking at increasing cloud. We're looking at decreased cloud costs. Now, the beautiful thing about this is this does not need internet. Don't need to be necessarily internet. We can even do an on-premise. Some of the hospitals that we have been talking to are very wary about putting their data on the cloud. That's okay. You buy a server with a GPU and put it up in your own premise. So you don't need internet. You don't need the external data. Your internal data, it can scheme through all of this. GPTs are assisted by what is known as LLM, large language models. These large language models have huge amount of necessary data, huge amount of data. All of this data, it actually is already built into this GPT, and then it schemes through your data and then gives NLP based output, natural language processing. So interactive outputs can be got. So this is very encrypted. It has extremely low law compliance, very compliant to the personal data protection bill, which is come up now. And there is a lot of audit protocols which are customizable, specific to your organization, that can be done. This as compared to a GPT, let's say, why not I use ChatGPT? Now, ChatGPT is a public platform. When you give your data, it is public data. So all of these cloud-enabled GPTs are public information. We are here talking about your GPT just for you. Now, you can put it up on the cloud, but it can be your personalized private cloud, which is not accessed by anybody else. Moving forward, so we have interoperability. You have your hospital information systems, you have your electronic health records. We will give access, the OLGPT can talk to all of that. So there is interoperability. There is high level of transparency, that is already built into this, and extremely private. So therefore very secure, very, very secure. Now, and therefore a detailed patient consent and education programs can be done just tailored to your organization. This, my dear friends, is what OLGPT, is a product we've done here in Bangalore and Chennai by our team, is available for deployment. We can do a POC. We can demonstrate that. You will get a demonstration right now. In another 5 minutes, you can see the product. And if you want it to be deployed in your organization for a limited period of time, we would be more than glad to come and do it without any commercial obligation. And we'll be more than happy to assist you in your AI journey. Begin your AI journey now. It's not too late, but your time is ticking. So let's move on to our live demo. I would request my colleague Raja to showcase a demo. After the live demo, we can have a free flow chat. Ask whatever questions, we'll be more than happy to give you. Raja, over to you.
Thank you, sir. Renika, can you actually help me share my screen?
Sure, Raja. Can you please share the screen now?
Yeah. Please do let me know.
Yes, we can see the screen.
Okay. So yeah, thank you everyone again. Thank you, Ram, for your interesting insights on what's coming up. So yes, we do have a solution which exactly works on the large language models. We have actually trained this model with a lot of medical public related data, and then today the demo what you are seeing is just a small snippet of what we can do. But yeah, this can be completely customized when we actually come and deploy it in your environment. This is not like a SaaS-based solution like the way ChatGPT is all about. At the same time, this can integrate with your hospital ERP or your inventory management system, and it can actually give you a one single chat window about how a particular patient was diagnosed with something, what tests were conducted, what are the medications which have been actually given, and of course, what are the next steps which are there for that particular patient. So today, our demo is focused more on the patient and the ecosystem surrounding the patient, but that doesn't mean that we're only related to this. We can actually work on imaging. We can actually work on integrating with your hospital management system to, to give a seamless experience for your customers to find the right doctor, to find the right next steps of what he or she has to do. And at the same time, we can integrate with any of your existing phone apps which you are actually providing to your existing customers. So let's start with a basic example. Like, I'm sure everybody want to know what is the name of what we are looking at. So what you're actually seeing, that I'm actually, while I'm talking to you, I'm again typing these things. And this is completely related to medical fields. For example, if I actually want to ask it some question, like for example, what is the capital of India? It would really give an answer like, of course, most of the GPTs today, they provide you what is the capital of India. But since this is focused majorly on the medical and medical research, it would actually try to bypass that particular question. Now, let's actually also saying that, let's ask it some decent question in terms of technology. Like, if you remember the olden days, Nokia systems, Nokia phones, we used to have a game called Snake Game. Let's see if it can actually write. I'm just trying to do this just to let you know that saying that, anything other than the context, if you're asking, the system will not answer it, which is what most of the systems which you're actually looking at it. Now, in this, we did feed in some kind of a simulated data. We actually generated with one of the generative AIs. We actually have generated some, patient discharge summaries, and we've actually loaded this into the system. Let me actually start by asking. So this is all some cancer-related information, cancer-related patient information we have fed into the system, and then you can actually see saying that I've actually asked about one particular cancer related thing, and it just said that out of the whole information which we've given, only one particular person named Sophia Nguyen, she was diagnosed with ovarian cancer. Okay, let me get some additional information about it. something like discharge summary. Now, what the beauty about the whole system is, this is all working in a single system. It's working in a very small single system. So nothing is going out. All the questions are again confined into this particular system. You could see the discharge summary. We just asked for a discharge summary for Sophia Nguyen, and then we get a discharge summary. Based on the discharge summary, I have some questions like, what is the medication suggested? I can ask a question. See that these are the medications which are suggested. One of the medicine, I actually have a doubt on it. Let us ask, are there any side effects for this? The medicine name is tamoxifen. Let's see. Yeah, so it is actually giving a huge list saying that we'll have nausea, vomiting, abdominal cramps and bloating, weight increase. These are, of course, few of the side effects for tamoxifen. But one of the important things is, because of all these things, I also want to know what is the medication, what is the kind of food which Sophia should actually eat. And you could see that the system has actually come back and said it should be some bland food, small frequent meals. She should stay hydrated. And because she's actually going through chemo, she actually has to have high protein rich food. But one of the important things is the way the diagnosis happened. What are the tests which have been conducted on her? So you could see that there are some physical examinations, which were actually revealed. One of the important things you could see from the exit summary, she's actually looking at having a complaint with respect to abdominal and the pelvic pain. So that's the reason there is a physical examination in the pelvic part, and then there are some imaging studies also which will actually done. Now this is about a particular patient, right? Now we can also ask for some generic information, like let's assume that somebody has to be administered glucose, for example. So let's see what should be the right quantities of glucose which can be administered. Now, again, all of this information can be customized based on the data what you have. We can actually ensure that only your data comes and no other data comes in as part of the responses which are there. Let's take one more question. Some kind of a liver infection. Let's assume I have a bad liver. There is a huge definition for what I mean by bad, but what kind of medication can be actually taken for it? So the system has a capability where it can actually search through all the various kinds of data which we have ingested, and then comes up with this kind of a outcome. Other than this, let's assume that we want to ask for some specific disease related information. One of the most commonly seen diseases nowadays, which is very subtle but many of the people are getting through, is a autoimmune disease. Let's ask, what is autoimmune disease? Very beautifully, the system actually gives some details about autoimmune disease. But the most important thing is, what are the symptoms? I'm actually keen to know the symptoms of that particular disease. It gives me the symptoms of the disease also. I'm reiterating, all of this is based on the public domain data, what we've actually fed in. But when we come to your organization, your environment, your clinic, or your hospital, we will actually feed in the data what you are actually providing. So What I'm showcasing to you is a sample example of the brain, what we have actually built. But the data, we will actually feed in the data. But nevertheless, if you still want us to actually continue with some kind of public domain data, yes, we can actually come default with this kind of a data. Let's take another simple example. Let's take a one of the exit summary or the discharge summary of one of the users. You could see I just copy pasted a big huge chunk of data. Now let me actually submit it, and then based on this data I have submitted, I can actually start asking questions. I can ask questions basically like, the name of the patient is Daniel Martinez, and for this kind of a patient, what should be the diet plan? Right, it actually gives us information, and then we can also ask saying that, what is when is his next visit to the doctor? And one of the most interesting questions which all of us would actually like, can he go on a long travel vacation? Of course, the system is advising, not to travel for long periods because this patient is a gastric cancer related patient, stage 3, and there are very high chances of these things recurring. Now all of this the system has identified just based on the discharge summary which was actually provided. Now this you could actually give it as part of a phone app to your users who are actually coming in, who can actually talk much with their system, and at the same time they can actually get enough insights on what all are the medication the doctors are actually providing to them, what are the side effects, when to take what medicine. All of these things can be taken in the chat. We are actually working on multilingual voice based questions. So now going forward, probably in the next couple of weeks, you can start talking to the system in your local language like Tamil, Telugu, Hindi, or Bihari, and you can get answers and replies in your own native language. And this is one of the very big breakthroughs which we're actually looking at. The other big breakthrough we are actually working on is you can start uploading your scanned images, like um, uh, something like your MRI report or some kind of X-ray report. The system will have a capability. Of course, we have to work on majority of your past scanned images and MRI reports. But the key here is we have a capability where we can actually do a vision-based control and AI analysis on top of it. I'm actually at the end of the demo, and if there are any specific questions, we'll actually open it up for the Q&A now.
Thank you for the demos, Raja. We have one question from one of the attendees. So that is, what data is used to train the model? Can you please take up this question?
Yeah. So the whole of this data, what we use are two kinds. In the demo, what I showed, we use public domain information, especially the cancer patient related information. We have actually sourced it, simulated it on a different generative AI, and at the same time, we actually have pulled in some additional information from the public domain. But when it comes to you, we will work on your data. So I'm sure as a clinic or as a hospital, you will have your historic data. Now, since this whole system is confined to your environment only, like once I deploy it and go away, even my team will not have access to your generative AI system. Only you and your team would actually have access to it, and this would get trained on your environment. Yes, if you give your data, it will be in your environment only. We will give our engine and will deploy it in your environment, and it will be all in-house. Nothing goes out of your environment. Any other questions? Renuka, you can actually enable the voice for everyone so that they can ask questions.
Yes, yes, you can ask questions now. You can raise the hands. I will enable so that you can ask the questions directly. Anyone have any questions to ask? Okay. So yes, we do have few couple of questions, Raja.
Please go ahead.
Mano, you can talk now. You can ask question. Manohar, you can ask question now.
I don't think it's happening for him. Can you please enable for Padma Priya madam?
Okay, sure.
Yes, ma'am. You are online now. You can ask your question.
Yeah, so if you're going to give your engine to us,
Yes.
So you, what is the configuration of the system you require to deploy your engine?
Yes, ma'am. We will actually provide you the configuration, but there are a couple of parameters for it. Like, for example, it depends on the amount of data what you have, number one. Number two, how many concurrent users you want them to access the system. Based on that, the configuration changes. But predominantly, in fact, the demo what you have seen, I can run it on my, I have a M1 Mac, and the whole environment I can actually run without seamless experience on my M1 Mac if it's a single user. So we could actually go from as low as that to a high-end GPU based system. It all depends on how many concurrent users and what is the kind of data you have.
To begin with, to test your engine, we
Yeah.
may not use multiple concurrent users. It may be one or two users who will be randomly checking your how precise the system behaves.
Yeah. So basically, we are looking at a basic configuration of a 16 GB RAM, 8-core system with a 8 GB GPU memory in it.
Okay. Fine, you share that to me in my mail. I will check it internally and come back. Definitely, I have desire to take up this AI journey because I represent a cancer care hospital, and we generate more text-based data. And like every patient is unique. As I observe the kind of patients coming to the hospital, every patient is very unique. And the day like the tests that are being done are all the genetic tests or tissue-based tests. So it's more of text-based reporting. So definitely, the generative AI will be of greater use for reviewing or going back or fetching the past patient details, referring to it, and all that. This is definitely going to play a good role. But primarily, in the initial days, I would like to deploy it as a test, as a test environment, and then like to ask my doctors to observe whether they are finding it comfortable using this, and then concurrent users and bigger deployment calls we can take later.
Ma'am, we can do that.
Okay, so yeah, definitely it is very interesting to understand about this. I'm very keen on understanding, and I'm very keen on traveling more with you and take up this generative AI journey.
Ma'am, pleasure is ours. Thank you very much. Renuka, next question.
Yes. Manor, can you speak? Do you have any audio issues over there? I think there is issue.
His audio is not enabled.
His audio is enabled. I think I will read up his question. So his question is, what data is okay that we have addressed?
Yes, Manohar, if you can actually type in your question, I'll actually pick it
Yes,
up.
yes.
I'm going to
One more question. One more question I wanted to ask. See, you said that you will deploy your engine in our system and you will not disturb it anymore. So, are you confident that that intelligence will build on its own? It doesn't require any tweaking or any further attention is not required for the engine?
only when I'm actually creating a baseline, which is the learning time, the LLM learning time, which is your sample data which you're actually providing. Only at that time, my team will be present to actually do that particular loading time. But once it is done and the system is actually handed over to you, there's no tweaking which is required, and no data again, as I said, will go out.
Okay, that's very important. Yeah, like the use case you showed, like Sophia's, like a summary. From her summary, you were able to make a lot more queries. Similar kind of a situation is will arise because we already have got more than 5,000 patient records. And out of that, retrieving, let's see how many patients have come with, say, for example, oral cancer, and how many people came with oral cancer who had a problem with, like vocal cord, and how many patients underwent a speech therapy to come over. Something like that, just giving a random example.
Yes, ma'am.
Like that, doctors will be interested to, dig the data, like get more statistics out of it to do one to create their papers, case study papers. Number two, to compare the treatment that was given between two different patients with the same kind of problem. What was the treatment that was planned for that person, the previous person? So that kind of a comparison they tend to do. That's what I observed. I'm also very keen on understanding like how do they do their diagnosis and what are the parameters they are looking in for in arriving at a diagnosis, and how do they do their treatment plan. And especially with cancer care, the treatment plan, like they do with there is a big protocol associated to it, and the data that they collect for the cancer patients, the data they collect is more, and the number of sessions they do for the care and the cure is more. So if you take it as a chemotherapy, then it is 10 to 12 sessions of chemotherapy a patient has to undergo. Radiation again requires 10 to 15 sessions. So every session, what is the improvement? How the patient was progressing? And between in the first patient and the second patient, what was the difference? What is the prognosis? All those things they are analyzing. So I also am interested in understanding what is that, what are the different parameters they are looking in for, and how do they arrive at their diagnosis and the treatment plan. Definitely, I'm interested in having this engine in house.
Yeah.
Let's take the discussions further.
Yes, ma'am. I'll connect with you offline, and then also I'll ask one of my sales teams to set up a call with you so that we'll again have another round of discussion.
Thank you.
Thank you, ma'am.
Thank you so much.
Yeah, I'm reading some questions from the Q&A. One of the questions was like, what is the amount of data required in terms of size? See, basically, it's the different kinds of data. Whatever examples you have seen, I just was able to simulate only 50 numbers of the patient discharge summary, and you were able to see it. But that doesn't mean that the accuracy is actually is the same. The accuracies will increase the more and more different kinds of data which you actually put in. Now, this also would answer the next question, saying that for example, a diabetic cancer patient, in my earlier patient, I've actually have proposed metformin. So the next diabetic cancer patient, will I again propose metformin? Probably not, because the intensity of the diabetic readings might be slightly different for the next patient. So can AI automatically suggest a quantity and a particular kind of a drug? It can, based on the past learning, but at the same time, there is always a fine print which the AI says, saying that please refer to your doctor. Please consult to your doctor. Like in this example, the reason I've actually put that, I have a bad liver, what kind of medication I need to do? The reason I put that is just to show that AI has a capability, but the onus AI will not take if the user is actually taking that medication. The patient still has to go consult his or her doctor, and take the appropriate medication based on that. And so do you have API based access to EMR and EHR? We do have a capability to do that, but again, for these things we have to go through a clinic or in a hospital. So the system has a capability to pull those execute those APIs and pull that data, but we have to go through your esteemed hospital, and what are the APIs are actually being triggered will be under the name of your hospital only.
Raja, we have one more question from Manohar. Like, does this AI affects the medical coding?
Okay. It actually is only a tool which will advise you something. It is not something which is going to change the way the existing medical system or the scenarios are actually running. Consider AI like your best friend who is going to advise you something, but end of the day, you as a doctor or a practitioner, it's under your discretionary whether to follow your friend's advice or not. So is it going to change something? It is only going to reduce the amount of time which you or your colleagues are actually going to think on a particular problem, but it's not going to change that whole the script, what the whole medical coding which actually happens. There are again a couple of questions. What we would actually do now is, since we are started 15 minutes late, I actually have continued till 7:15. Please drop in for the next 5 minutes. Please drop in any other questions you have. We will collect all the questions in the Q&A, and we will reply back to you on your email IDs. Are there any questions which people want to ask verbally?
Verbally, no one has raised the hands. We have few couple of questions people have asked here.
One question let me take. Medicine advances rapidly while using all our 10-year records. How to prevent it from suggesting obsolete protocol? It could be harmful. Yeah, true. Absolutely true. One of the things what happens in these generative AI is, consider generative AI like a 5-year-old child who understands a language. That's all. But do I have to make that particular kid a lawyer, a doctor, a policeman, or an engineer? Is based on the kind of data I'm actually feeding in. But while I'm feeding in the data, I can also say after 2 years or 3 years, saying that, hey, that has actually gone obsolete, don't use it. So this is how the regular training also helps us out. And this training is not done by us, but you as an end user, you can come back and say, hey, these protocols have become obsolete, so don't look into it. So the generative AI is a self-learning system which actually will learn based on the feedback what you are actually giving to it.
So
Yeah.
our next question is, what is the format of the data we need to input?
See, it depends. So we can actually support multiple formats. We can scrape a particular website completely, and then we can use HTML from the website. We can take PDF files. like, there are a lot of medical reference books are available in PDF file, and then we can actually use that. We can use Excel sheets, we can use Word documents. You give an image, and if there is some text written in the image, it can actually go through that image and then read it. The formats of data are actually huge. And one of the things is, I'm slightly getting into the technology angle, which is the IT technology angle. There's something called structured data and unstructured data. Generative AI works very well for unstructured data also. So you don't have to worry about, hey, is my data clean? Is my data like this? Just that the way I'm asking the questions to AI would be slightly different, but AI will be able to read all of that.
So our next question is, can this AI API be based access to EMR or EHR?
I did answer that earlier. Yes, we do have capability to trigger any kind of APIs, but again, these APIs have to go through your your organization name. It will not go through our system.
So there is one more question. Can AI give personalized drug or dose suggestions based on previous data in future if there are possibilities for personalized medicines?
Again, I did give a small example with the liver disease related example in the demo. AI does have a capability, but again, there's a fine print which AI will actually say, saying that please refer to your doctor or a practitioner. Yes, answer is yes. AI has a capability by looking at the past data and the current data which it is actually ingesting. But at the same time, there is a fine print which under every share market document or any legal document which is there, AI also puts a fine print saying that please refer to your doctor.
So will it accept handwritten prescriptions also is one of our next question.
Very good. That's an excellent question. We are working on the handwriting recognition model. Today, we are actually able to detect only the printed text on an image. But if you're actually scanning, we are actually working on it, and very soon we'll actually launch it.
So what will happen to the learning of this